Now, let's start with Thevenin theorem. Thevenin states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source, VTH, in series with a resistor, RTH. And what is VTH? VTH is the open circuit voltage at the terminal, and RTH is the input or equivalent resistance at the terminal when the independent sources are turned off. So suppose here I have a very complicated circuit where there are three sources and we have an RL which is in between node A and B. Now, of course, we will try to, this is our load. So now let us try to obtain the VTH and RTH of this circuit. Now to obtain the VTH, what we should do, we had to remove the voltage, remove the load, remove RTH here. So we have to remove this one and try to measure the voltage between A and B. In that case, that will be the open circuit voltage, and that will be our VTH. Now, to determine the RTH, we had to remove all the sources, replace with the source circuit. Okay, so I remove all the 4 sources, and let us assume that there is no internal resistance. If there is an internal resistance, you have to put a resistor here, if there is a given internal resistance. But if there is no internal resistance, you have to keep it shorted. So now, what you should do, put this to measure the ohmmeter, use as an ohmmeter to measure the resistance between A and B. Okay? To measure the resistance between A and B, and that will be your RTH. Okay? Or the equivalent resistance at the terminal where the independent source are turned off or removed. Okay, after that, what's the next procedure? So we now have the VTH, we now have RTH. Next procedure is just to connect it in series. Our source will now be a VTH, and our resistor RTH in series with VTH. And what about RL? RL, we can now connect RL on the point A and B where we removed it before. Let us connect it here. And then we can calculate the value of IL. What will be IL here? Of course, IL will be equal to VTH divided by the total resistance. And what will be the BL? BL using this formula, Ohm's law, IL/RL. Or we can use the voltage division rule that BL will be equal to RL multiplied by VTH divided by RTH plus RL. Okay? So we had simplified this very complicated circuit into a very simple circuit. Now, Norton's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of the current source IN in parallel with the resistor RN, or the Norton equivalent resistance, where IN is the short circuit current through the terminal and RN is the input equivalent resistance at the terminal. So you can see here that RN is equal to RTH. Again, RN is equal to RTH. So now we will have again similar circuit using I Norton. What are we going to do? We have to short circuit this wire, remove the RL, short circuit this terminal between A and B, and try to measure the current flowing here. How to measure the current? You have to, of course, in practical, use a multimeter to measure it, right? Or try to solve it manually. You want to know the current between A and B. Okay? So after that, when you obtain the short circuit current, it will be connected in parallel with RN. How did we obtain RN? Similar what we did here. We obtained RN RTH here, similar procedure. So now, after that, where are we going to put the load? In parallel with RN. So now we can apply the current division rule. What will be IL? IL will be equal to ISC multiplied by RN. divided by Rn plus RL, right? So this is by current division rule, and you can get the BLIL. Okay? Now, maximum power transfer. So from this circuit, what is the maximum RL? Wait. What is the maximum value of RL that can be connected across this equivalent circuit in order for the load to observe a maximum power? Okay? In order for the load to absorb a maximum power, or in order for the Thevenin equivalent circuit to supply a maximum power to the load. Okay? Maybe one application of this is our charger, mobile charger. They designed the cell phone charger so that it can provide a maximum power to the load, or to the cell phone that is being charged. What is the equation for power? Power is I squared R, right? And from this circuit, we know that I, the current flowing here, is equal to B over RTH plus RL, which is squared here. So, R squared, we square it and multiply by RL. Now, what are we going to do? We had to take the derivative. Okay, if you still remember your topic in calculus about maxima and minima. Why do we need to take the derivative in order to determine the maximum power? So as you can see here, this is the slope of a curve, right? What is the slope of a curve at maximum? The slope is equal to 0, because here, at this point here, there is dy over dx, right? Here, dy over dx, dy over dx, dy over dx. But here, what is dy over what is dy here? It's dy changing. It's not changing anymore. So dy is 0. So that means the slope at this point is 0. And then going down, we have minus dy over dx. It's going, there is a vertical and horizontal value for dy over dx. So now, we have this differentiation equation. The derivative of u over b is equal to b du minus u db over b squared. Derivative is a rate of change, actually. So let us apply this derivative. We have u is equal to what? BTH RL, BTH squared RL, and then our b here, substitute b, RTH over RL squared, right? This is our b. Take the derivative. We have b du, b, this one, du, derivative of du, and then u db. This is u, right? U db. So db, and this is du, and then b squared. So this is a square here. RTH plus RL square. Again, you will square it. It will become RTH plus RL raised to 4. This is exponent, huh? Okay. So after that, so this is our result of our derivative. Simplifying the equation, we will have here 2RL. How it becomes 2RL? You just expand this RTH plus RL and try to simplify the equation. You can have RTH plus RL minus 2RL. So RTH plus RL minus 2RL, it will become RTH minus RL. And then you equate it to 0. Why we equate it to 0? Because the slope is 0. If we equate it to 0, we can eliminate this part of the equation. Then we will have only RL minus RTH minus RL equal to 0. Right? This part of the equation will remain. We will have RL equal to RTH. It means to say that in order for the circuit to obtain a maximum power transfer, the value of RL must be equal to RTH. Right? Okay? So now, let us now try to substitute the values. BTH squared over RL plus RTH. I will substitute here to RL. So square it. Okay? So because this is square Okay, BTH square. Oh, so this is wrong. This is inside the the parenthesis. So it should be square also here. So we will have P max is equal to 1/4 multiplied by BTH squared over RL, right? Because here we'll cancel RL here. So there is only one RL. So this is the equation for maximum power transfer.